Unicode, UTF-8, reading and writing to files in Python. I'm having some brain failure in understanding reading and writing text to a file, Python 2.4. U' capit \z1n, capit \xc3 /saw1n. So I type in capit \xc3 /saw1n into my favorite editor, in file F2. Then, what am I not understanding here? Clearly there is some vital bit of magic, or good sense, that I'm missing. What does one type into text files to get proper conversions? What I'm truly failing to grok here, is what the point of the UTF-8 representation is, if you can't actually get Python to recognize it, when it comes from outside. Maybe I should just JSON dump the string, and use that instead, since that has an ASCII-able representation. More to the point, is there an ASCII representation of this Unicode object that Python will recognize and decode, when coming in from a file? If so, how do I get it?
In the notation U' capit \z1n \n, should be just capit \z1n n in 3.x, and must be in 3.0 and 3.1, the \z1 represents just one character. \x is an escape sequence, indicating that E1 is in hexadecimal. Writing capit \xc3 /saw1n into the file in a text editor means that it actually contains \xc3 /saw1. Those are 8 bytes and the code reads them all. We can see this by displaying the result. Instead, just input characters like A in the editor, which should then handle the conversion to UTF-8 and save it. In 2.x, a string that actually contains these \escape sequences can be decoded using the string _escape codec. The result is a SDR that is encoded in UTF-8 where the accented character is represented by the 2 bytes that were written \xc3 /saw1 in the original string. To get a Unicode result, decode again with UTF-8. In 3.x, the string _escape codec is replaced with Unicode _escape, and it is strictly enforced that we can only encode from SDR to bytes, and decode from bytes to SDR. Unicode _escape needs to start with a bytes in order to process the escape sequences, the other way around, it adds them, and then it will treat the resulting \xc3 and \saw1 as character escapes rather than byte escapes. As a result, we have to do a bit more work.
Rather than mess with .encode and .decode, specify the encoding when opening the file. The IO module, added in Python 2.6, provides an io.open function, which allows specifying the file's encoding. Supposing the file is encoded in UTF-8, we can use. Then f.read returns a decoded Unicode object. In 3.x, the io.open function is an alias for the built-in open function, which supports the encoding argument. It does not in 2.x. We can also use open from the codec standard library module. Note, however, that this can cause problems when mixing read and read line.
Now all you need in Python 3 is open file name, our encoding equals UTF-8. Edit on the 10th of February 2016 for requested clarification. Python 3 added the encoding parameter to its open function. The following information about the open function is gathered from here, this URL. Encoding is the name of the encoding used to decode or encode the file. This should only be used in text mode. The default encoding is platform dependent, whatever locale.getPreferred encoding returns, but any text encoding supported by Python can be used. See the codex module for the list of supported encodings. So by adding encoding equals UTF-8 as a parameter to the open function, the file reading and writing is all done as UTF-8, which is also now the default encoding of everything done in Python.
This works for reading a file with UTF-8 encoding in Python 3.2.
If you want to celebrate, please consider subscribing.